Bismillahirrahmanirrahim. Okay, guys, now we shall see the scene of the distances in these planes. Okay, uh, we shall learn how to find the distance of a plane. Let me write this: the distance of a plane, first of all, from origin. Okay, secondly, from another plane, and thirdly from a point or maybe a line. Okay, now first of all, bacho, the thing is that if you have, for example, there is a plane which is 2x minus y plus uh, 2z, that is equal to, let's say, 12. This is the equation of the plane. Okay, so now, suppose this plane is over here, okay, and here is the origin, okay, and here is the normal to the plane, like this, okay. So, this normal to the plane is basically, bacho, that is a direction vector perpendicular to the plane. Okay? Acha. Now here it is n. So you see, when we say the direction vector, so this direction vector, you people know that you can simplify this. Okay? Right now, um, this normal is 2 minus 1, 2. Okay? You must have its unit vector. That is going to be, you see, this is 2 square plus, like if you find its magnitude, this is 4 plus 1 plus 4, that is going to be 3. So 1 over 3 times 2 minus 1, 2, that is the unit vector uh, parallel to this normal. So if you want to find this distance of the plane from the origin, you have to see that how many units of this are there from this O to this plane up to this N. If this unit vector is 1 over 3 times this, so that means this is going to be 3 times, this is basically 3 times this is going to be this normal. Okay, so to determine the distance of a plane from the origin, you have to have, like, normally the equation is r dot n, that is equal to, let's say this is a number k over here. Okay, if you make this n a unit vector, then you can change this with d. This d means the distance of the plane from the origin. So, how do we change a vector into its unit vector? You have to divide that vector by its magnitude. So you have seen that the magnitude of this 2 minus 1, 2 is 3. So we shall divide this side by 3, and you will divide this side by 3 as well. You get 4. Now this equation, which is going to be r dot, this is 2 minus 1, 2, and we have divided this by 3. So this means this is the unit vector. Obviously, when you have to divide it by 3, you will divide the other side by the 3 as well. We are dividing it by 3 so that we can have the unit vector of this normal to the plane. So you have this equal to 4. Now this equation has been written in the form r dot n, that is equal to 4. So this 4 is the distance of this plane from the origin. So whenever you have to write, you want to find the distance of a plane from the origin, you have to make sure that this normal should be written in the form that we have its unit vector. Now suppose there is another plane over here. Let me write the equation of another plane. Now suppose you have x minus 2y plus 2z. I'm intentionally taking this 1, 2, 2 because its magnitude is always 3. Now this is equal to, let's say, 21. So if you want to find the distance of this plane from the origin, you simply divide both the sides by 3. There is no need to go into the details of that unit vector thing. So this is going to be 7. So you just need this 7 here. The distance of this plane from the origin is going to be 7. Let's say you have a plane which is 2x minus 3y plus 6z. Okay, and that is equal to, let's say, 28. This is another typical vector 2, 3, 6 whose magnitude is always 7. So I'll be dividing both the sides by 7, which will give me 4. So that means the distance of this plane from the origin is going to be 4 units. So that is how you find the distance of a plane from the origin. You simply divide both the sides by the magnitude of the normal. You get the distance of the plane from the origin. Okay? Now I move towards the distance of a plane from another plane. When we say that we want to find the distance of a plane from another plane, we should be very clear that these two planes have to be parallel to each other. Obviously, you can't determine the distance between two intersecting planes. So, suppose there is a plane which is 3, sorry, let me change the color. Let's say this is 3x minus 2y plus 6z, that is equal to 14. And there is another plane which is 3x minus 2y plus 6z, that is equal to, let's say, 35. Again, I'm taking intentionally this 3 minus 2, 6, because 3, 2, 6, you see 3 square plus 2 square plus 6 square, that is 49. So its magnitude is going to be 7. So when you want to find the distance between these two planes, so you divide this vector by 7 and obviously this by 7 as well. So this is going to be 2 and this is going to be 5. So the distance between these two planes is 3 units. This actually means that both of these two planes, they are on the same side of the plane, of the origin. So the distance between these two planes is going to be 3. Suppose if this was instead, it was minus 14 here. So this will be minus 2. Now tell me, what is the distance between these two planes?
7.
7, because that means these are on the either side, opposite sides of the origin. One is maybe 2 units below the or towards the right or whatever on one direction of the origin. One is totally opposite to that direction. Okay. Now suppose if there was a minus here as well, and this is minus. Now what is the distance between these two planes?
3.
Yeah, that is going to be 3. Now they are both again on the same side of the origin. So when you define the distance between two planes, the planes should obviously have to be parallel to each other. And then you divide both the planes with their magnitudes. On both the sides of this equation of the planes, you determine these distances, and then you find the difference between them. Okay, now thirdly, the distance of a plane, of a point from a plane, yeah, of a line from a plane. Okay, for this purpose, I always used to give, I remember when we used to have this class inside the class physically, we're teaching. So I always used to ask the students, okay, let's find the distance of the point where the ceiling fan is fixed from the floor of our room. Okay, so now suppose you have a plane here. Okay, this is this is the a line on the plane over here. Okay, and here is a point from which you want to find the distance. Okay, so this one over here is sorry. There is a plane down here. Okay, and here's a point P. You want to find the distance between the point P and this plane. Okay, suppose we take this question over here. This point P is 4, 1, minus 5. And this plane has an equation which is 2x plus 7y minus 6z, that is equal to 14. Okay, when you find the distance of a point from the plane, guys, you just change your question into the distance between two planes. Because you see, can you give me the equation of the plane that contains the point P and is parallel to this plane with this equation? Yes, guys?
It'll have the direction vector that is perpendicular to
Yeah,
it.
they will have the same normal, okay? So this side is going to be same, 2x plus 7y minus 6z. The other side would be 4, 1 minus 5 dot. That is, you see, it is r dot n, that is going to be a dot n. So r dot n will give you the same 2x plus 7y minus 6z because the normals are same. And this would be 2, 7 minus 6. So you have here, this is 8 plus 7 minus 30. Yeah, so you have 15 here, okay? So, so these two, the plane that contains the point P and is parallel to this plane has this equation. So when you have to find the distance of the point where the ceiling fan is connected from the floor, you simply change this into the situation where you have to find the distance between the ceiling and the floor. Guys, got it? है ना? छत का और फर्श का distance
Yes.
find करना is same as finding the distance between that point where the ceiling fan is connected from the floor. So now the equation of this plane containing the point P parallel to the given plane is this. Okay. So what is this is the magnitude of this is going to be 2 square is 4 plus 49 plus 36.
The magnitude is under root 89.
That is a very bad kind of a question. You should have used some friendly numbers here. So we divide both the sides by under root 89. This is under root 89. I divide this by under root 89 and this is under root 89. What kind of a question is this? Anyhow, so this is going to be, obviously this is more. So the distance of this point P from this plane is 15 over under root 89 minus 14 over under root 89. That is 1 over under root 89. You can rationalize the denominator by multiplying. So this is going to be under root 89 over 89. Okay, let's see what is the answer to this. Okay. Oh, his distance is 31 under root 89. Come on. Let's check our working. We have made a mistake here when I was finding the dot product. 8 plus 15 minus 30 is going to be, let's do that again. 4 2s are 8. Okay. This is 31. Let me go back to this question here. The question says we have 4, 1 minus 5. So 4 into 2 is 8. 1 into 7 is 7. Minus 5 into minus, oh my God. Look at the mistakes I'm making. This is plus. This is plus. Guys, you didn't check that. So this is 15 plus 30. That is 45 instead. Is that so, bacho?
Yes.
That is 45. Oh. And then, yes, this is 45. So this one is 45 and the other one is 14. Yeah, that was given 14. So what is this 45 minus 14?
31. 31. 31.
31. Oh, this is 31. Is it right now? 31 under root 89?
Yes.
Okay. So you see, we really made some silly mistakes over here while going for the dot product. Anyhow, guys, I have told you how to find the distance of a plane from the point, from the origin, distance between two planes, and you change the situation where you had to find the distance of a point from the plane. You change that into the distance between two planes. And suppose if there was a line instead, Suppose there's a line on the ceiling, okay, which is going like this, containing this point P. So you ignore the line. Obviously, the line has to be parallel to the plane. ठीक है ना? So you ignore the whole line and you just take this point P. So finding the distance of the line from the plane is same as finding the distance of this point from the plane, first of all. And then you change that situation where you find the plane that contains this line actually. So you have the normal, you have the point, you write the equation, and you see you get to that. Yeah, guys.
Sir, but it would always be parallel.
It has to be parallel. Obviously, yeah, you can't find the distance between two intersecting lines or two intersecting planes or a line and a plane intersecting. You can?
If you do find the two
Intersecting नहीं
intersect,
मतलब sir
I can't hear you. So I have to finish this session here. Okay. Thank you very much.